This is Mr. Martin. These are video notes for Pre-Calculus Honors. We're still talking about section 8.6. This is video number 4 for the section. We're going to start out talking about counting techniques. So as we discussed in the previous section, the counting principle. If you are interested in determining the total number of outcomes, simply multiply all of the outcomes of each individual event. For example, a catalog offers chairs in a choice of 2 heights. There are 10 colors available for finish, 12 choices of fabric for the seats, and the chair has 4 possible designs. So we've got these 4 different characteristics. How many different chairs can be ordered? We're just going to multiply each of the outcomes. So we've got 2 times 10 times 12 times 4, which would give us 960 different chairs. Okay, so just a little review of what we've talked about already. So let's consider the following experiment. Each letter of the alphabet is written on a piece of paper, and 3 letters are chosen at random. So we're going to take the pieces of paper, we're going to throw them in a bag, and we're going to pick out 3 letters chosen at random. So there's 2 important questions in determining the nature of the experiment. So number 1, is each letter replaced before the next letter is chosen? So we'll say either with or without replacement. So this is important. And then 2, does the order of the letters matter in the result? So are we talking about a permutation or are we talking about a combination? So keep those things in mind. So let's consider the following 3 scenarios. Let's fill in the table. So we're again talking about picking our 3 letters out of the bag. So with replacement, order matters. So we have 26 choices for the first, and then we would have 26 choices for the second letter because we're replacing them, and 26 choices for the third. So these would be the number of possible outcomes if we were picking our 3 letters from the bag. Without replacement, order also matters. So again, we have 26 choices for the first letter, but now we're going to keep that out. So that would be times 25 times 24. And again, this is the same as 26 permutations of 3 letters at a time, which would be 26 factorial over 23 factorial, which is basically what we have over there. Okay, and then without replacement, any order, so the order does not matter. So we're actually going to have less outcomes, and this would be our combination. So this would be 26 choose 3, which would be 26 factorial over 3 factorial times 23 factorial, or this would end up being 26 times 25 times 24 over 3 times 2 times 1, which we could go ahead and simplify as well. So a note here is one scenario is purposefully missing with replacement any order, and this will be beyond the scope of our class for now. If you want some more information about that, track down one of the stats teachers at school. So these are 3 different cases. Let's take a look at another example. Let's use the counting principle to verify tossing 3 coins and counting the number of heads. Assume we are using a coin where the probability of the heads and tails are equal at a half. And then we're also going to do a tree diagram for this as well. So we've got 4 different outcomes here for tossing 3 coins. We could get 0 heads. Okay, so the probability of getting 0 heads is not getting a head on the first toss, not getting a head on the second toss, and not getting a head on the third toss. That would be a half times a half times a half, or 1/8. Alright, and then getting 1 head. Okay, so if we got 1 head, this would be 1/8 plus 1/8 plus 1/8 or 3/8. Okay, and each of these 1/8 comes from the fact that if we got one head, it could either be on the, we could get the head on the first one, or we could get the head on the second one, or we could get the head on the third one. So it would be heads, tails, tails, or tails, head, tails, or it could be tails, tails, heads. Okay, and the probability of each of these would be 1/8 for that one, 1/8 for that one, 1/8 for that one, and then we would add all those together. Okay, and then the probability of getting two heads is going to be the same. It's going to be 1/8 plus 1/8 plus 1/8 or 3/8. Again, our different possibilities could be heads, heads, tails, or we could have heads, tails, heads, or we could have heads, sorry, that should be tails, tails, head, head, head. Okay, and again, the probability of each of these is 1/8. If you have questions about that, make sure you ask me. And then the probability of getting 3 heads would be heads, 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 and that probability would be 1/8. Okay, so 0 heads over here, just to be consistent, that would be 3 tails. And we can see if we add all these up, 1/8, 3/8, 3/8, 1/8, that gives us 8/8, which is 1. Alright, now sometimes it might be useful to make a tree diagram, and it'll make it a little bit easier to see the outcomes here. So tree diagram. So we're going to start with our first toss, and our first toss, it can either be a heads or it could be a tails, and the probability of each of these occurring would be 1/2. Alright, so if we tossed heads the first time, then we were going to toss another coin. Again, it could be heads for 1/2 or tails for another 1/2 probability. Or if we got the tails first, we could do a heads for 1/2, or if we tossed it, it could be tails for 1/2. Okay, so this first column here represents the first toss, and the second column here represents the second toss. So we're going to need one more column to represent the third. So another heads, tails from this one. Each of these is a 1/2 probability. Heads, 1/2. Tails, 1/2. Heads, 1/2. Tails, 1/2. So you can see this could get quite cumbersome if we have larger experiments, like tossing a couple of die and maybe tossing some coins in there. It could get kind of large and unwieldy. So each of these branches represents a different outcome. So if we follow this first branch out, it would be heads on the first toss, heads on the second toss, heads on the third toss. So that would be H, 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 and the probability there would be 1/2 times 1/2 times 1/2, which would be 1/8, which is the same as what we got before. So why don't you go ahead and see if you can finish out these branches here with the outcomes. And you can pause the video, and then when you restart it, we should have all these filled in for you to check. So pause now and fill in the rest of this tree diagram. Okay, so here's the rest of our tree diagram. Hopefully you got the same things here. So you can see that each of these branches has an equal chance of occurring. So again, if we're looking for 2 heads, we would look at these branches that have 2 heads. So it would be this one, and this one, and this one. These 3 have 2 heads, so that would be 1/8 plus 1/8 plus 1/8, or the 3/8 that I got up above, the 3/8 that I got over here for 2 heads. Okay, so that'll be the end of this video. If you had questions, make sure you write those down and ask me, and we'll see you in the next video.